Hello everyone and welcome to the 10th sheet metal exercise, and here we are going to learn how to import the sheet metal parts and how to assemble them by using the smart fasteners in SolidWorks. So we are used to creating the holes which are needed for the fastening purposes in the part modeling itself, but now we are going to learn two new ways on how to create those holes in the assembly itself, so that less work has to be done in the part modeling stages. Okay, so before just importing anything, I would just like you to disable a simple feature known as 3D interconnect. So the feature is located in options and import, and here it is. So just disable it. Okay, so the 3D interconnect feature is it's quite a revolutionary technology from SolidWorks or Dassault systems, which means that no conversion is needed when you import the geometries from from Siemens NX or Solid Edge or Cartier. I mean, this has some really good implications in the industry, but for now, for our purpose, this thing is harmful. So let's just deselect it. So just deselect or just disable the 3D interconnect and press OK. Okay, so now we are good to import our geometry which is there in the Moodle. So let it process. Okay, so the first thing that we should do is change the units to IPS, and also let's make the edges visible because they are not visible, and it will look a bit nicer. Okay, yeah. Okay, so things to notice: number one, there are a total of 4 parts: the housing, the guide 1, the guide 2, and the guide 3. The names are right here, and these are the minus signs which exist. Okay, the signs here, it means that the constraints are underdefined. So the best way is to constrain all the 4 parts in such a way that they are fully constrained, and if they will be fully constrained, the minus sign will get removed. So this is a kind of underdefined which we have in the sketching part. Okay, so I mean, if you have a minus sign in your assembly and that is not a good part, so you have to work on how to make the assembly fully defined. Okay, so let's first make the housing fully defined by just mating the planes of the housing with the planes of the full assembly or the SolidWorks global axis. So just expand the housing and select both the front planes and go to assembly, mate. Okay, so now they have been mated, or they have been coincided. Select the top planes, mate, click OK, cancel. Right plane, mate, OK, cancel. Okay, so as you can see, the minus sign has been removed because we can no longer move the housing from its position no matter what you do, but we can move the guide rails, and hence the minus sign exists. Okay, so now this is not a sheet metal part. This is made from a sheet metal part, but it has lost its feature or characteristic. So now let's quickly change it to sheet metal. Now to do so, we need to get into the part modeling level. Currently we are on the assembly level, so select the name, right click, and go here, which is called the edit part. Okay, so we need to save the file before continuing ahead, so I'll just save the file as 1 and save all. Okay, so currently now you are on the part level and not on the assembly level, and see the name has been blued out, which is an indication that you are on the part level. Okay, before doing anything, please change the units, because your features are not going to work and you are going to have rebuilt errors for sure. IPS. Okay, so go to Sheetmetal and insert bends and select this face. The bend is 0.01 inches and all the default features are to be accepted. Click OK. Okay, so it was expected that auto relief cuts should be made, so okay. So as you can see, it has been converted into sheet metal files or parts. So we need to do this for the remaining three. So right click, edit part, units, IPS, insert bends, select the select the face, accept all the default features. Okay, exit. Card number 2, which is this. Right click, edit part, units, IPS, insert bends, the fixed face. Okay. Card number 3, edit, units to IPS, insert bends, fixed face. Okay, and exit. Okay, so now this part has been converted into the sheet metal parts, and now let's just go ahead and fix the rails here. So the dimensions of the rails are not given so as to where to fix them, because it is beyond the scope of this tutorial. So we are just going to fix them on this plate. Okay, so now we know that the bottom of the plate is going to get flushed with the top of the housing, so we'll just add a mate of coincidence. So select this and click execute. Okay, so as you can see that the plate is still free to move, but only in parallel or in coincidence with the top face. Okay, so we are just going to arbitrarily fix this this guide. So just right click and select fix. Okay, so now you can see an F here, and this means that you have fixed the assembly, which is also not a good thing, because everything should be constrained with each other. But for now we don't have the dimensions because it is beyond the scope of this tutorial, and so therefore we are fixing this. Okay, so same has to be done with the remaining 2 guides. Okay, just position it arbitrarily and coincident. Okay, X, select this and fix it. Okay, and now the last one. Okay, and let's fix it here. Fix it. Okay, so now everything has been constrained and it cannot move freely. So now let's make the holes. So just make it normal to you. Okay, so now there are 2 ways in which you can make the holes in the assembly, which is can be found in this assembly features drop down list. So we are going to learn today the hole series and the hole wizard. I mean, the hole wizard should be known to the most of you because it has been covered in the previous in the engineering drawing and design course. Go ahead and place the holes like this, okay, and make them all in a line, a straight line, and the dimensions in between are 4 inches, also 4 inches, and from here to here it is 1.4, and from here to here it's 0.325. okay, done. Okay, so you are done with the dimensioning. Now let's proceed to the second tab. Okay, so we want to make a countersink. The standard is ANSI inch, the type is flathead screw 100, and the size is 4. Okay, so accept all the default features or the default parameters. Let's go to the second one. Okay, so you can either select this auto size based on smart hole, or you can just deselect and go to I mean you can input your desired manual inputs from here. For here the custom sizing would be 0.1285, which is similar here, 0.1285. It's better if you choose this auto size based on start hole, so it takes all the inputs from the previous tabs. Okay, so in the fourth tab you are free to choose the auto sized start hole, but it creates some problem for me, but so I'm going to manually input all the inputs. So the type we want is the tapped hole. The size is 4 to 40 inches. No, it's a different thing. The end conditions for the tap drill is through all. Okay, and we want a thread call out obviously, and the custom sizing or the space between these two were 0.1285 inches. As I didn't select the auto feature, I have to manually input this all. Okay, 1285, and okay, so now here is the perfect countersink. So now let's create the holes for this guide and the second and the third guide. So make this sketch normal to you, assembly, and now let's go to hole wizard. So the hole wizard is pretty much simple as when compared to the hole series. So select the type of hole, which is the countersink, standard as ANSI inch, the type as flat screw 100, size as 4, fit normal, and the end condition is through all. And if you select the show custom sizing, you can see that the spacing is also 0.1285, which means that the holes which are going to get created will be the same as we made in the hole series. So now just go to the position, and we have to do the same thing that we did in the previous step. So we need to dimension it. So let's quickly make them all in a straight line. Okay, and this thing is 4 inches. Okay, 8 inches, no worries. And from here to here it is, smart dimension. From here to here it is 1.4 inch, and from the sideways it is 0.325. So as you so there's something which is not defined, which is the hole in the middle, which is 4 inches from the top. Okay, so now it's fully defined, so click OK, go to type. So now basically everything should be okay, and we should have identical holes from here and here. But I'm also going to make holes in the third rail also. So I'll just go to position and I'm going to place the extra holes on the third rail as well. So you are free to dimension it as you like, but I'm just going to keep it like this. So now let's just execute the command. Okay, so as you can see, the countersinks has been created, and all the countersinks, the 9 of them, should have equal sizing. So now let's just go ahead and click the smart fasteners, click OK, and in the selection tab just select any of the faces in the smart fastener and click populate all. So it is basically going to populate all the areas with the appropriate flat head screw. Okay, so just deselect the auto update length, because it will automatically get deselected when we change the length. Okay, so the length is 0.125 because we don't want to add any bushes or nuts, and the driver type is the crosshead, and the thread length is 0.125, and the thread display should be schematic, so as we can see the threads properly. Okay, so I think this is it, or oh no, yeah. So this the changes you made are for the group 1. Now we have to do the same thing by selecting the group 2. So go ahead and select group 2, deselect the auto update length. The length is 0.125, the thread display is schematic, and everything seems okay, and go ahead and populate them all. Okay, so as you can see, the screws have been created, and this is how we use the smart fastener features for the assembly purposes, and I believe this is the end of this tutorial. So if you guys have any doubt regarding any tutorials, or you want additional help, please feel free to contact or feel free to post in a thread on Moodle. I thank you for watching the tutorials, and I wish you luck.